Hello and welcome to the first section in chapter 11. This one's a little bit longer. We're going to be graphing square root functions. And you'll see on the calendar that we're going to be spending 2 days with this. So you guys can kind of choose how you tackle this video if you want to break it up. I don't know how long it's going to be, but just kind of looking at the slides that I have, and traditionally this takes a little bit more time. So just kind of keep that in mind as you're planning. A radical expression is an expression that contains a radical, so it's a square root, cube root, or another root. Now, you guys are only going to study square roots this year, and then when you get to Algebra 2 in high school, you're going to study cube roots and things like that. So we're just going to focus on square roots, and this is the parent function. And down here, parent function is the most basic square root function there is. So step number 1 for this, find the value that makes the square root part equal to 0. And so that would just be 0 for this one. That's going to be your starting value. So plug in 0, square root of 0 is 0. Plug in 1, square root of 1 is 1. Plug in 2. Now if I plug in 2, the square root of 2 is, I don't know. The square root of 3, I don't know. The square root of 4, I do know, it's 2. So I'm going to plug 4 in for my next value. And then I'm going to plug in 9 for my next value, just so I get whole numbers, so I can make my graph. Now, are the other points on here? Yes, they are on there. There's an infinite number of points on here. However, I only want nice numbers to plot. And if I did 16, it'd be 4. And so this is our square root function. Kind of looks like half of a parabola that's tipped on its side. Okay, so here we have 3 times the square root of x, and it says to identify the domain and range, compare the graph to the function of compare the graph to the parent function. So again, the value that makes the square root part equal to 0 is 0. So that's where I'm going to start at. So the square root of 0 is 0. 0 times 3 is 0. Next number is I'm going to plug is 1. Square root of 1 is 1 times 3 is 3. Next number is 4. Square root of 4 is 2. 2 times 3 is 6. Next number would be 9. Square root of 9 is 3. 3 times 3 is 9. And then I'll do 16 as well. Square root of 16 is 4. 4 times 3 is 12. And then we can just plot our points. 0, 0, 1, 3, 4, 6, and 9, 9. And it has the same shape as the other one, only this is called a vertical stretch. We've talked about that before. Vertical stretch of 3. Okay, now the domain and range. The domain is my x value. So here x goes from 0 to infinity. So x has to be greater than or equal to 0. The range starts at 0, goes to infinity. So the range, the y values are greater than or equal to 0. So these are going to change quite a bit actually. So they're not always going to be greater than 0. So when I say 0 to infinity, I just say x is greater than or equal to 0. And y has to be greater than or equal to 0. Okay, let's go through another example here. This one's got 2 things going on. It's got a negative and it's got a half there. So again, I'm going to start with 0, because if I plug in 0 here, that makes that 0. Now, if you haven't noticed, we have not been using negative numbers because I can't square root negative numbers. We know that those don't exist. So plug in 0, square root of 0 is 0. Oops, I should draw a mirror up to here. Times negative 1/2 is 0. Plug in 1. Plug in 4. Plug in 9. Let's see, square root of 9 is 3, and then 3 times negative 1/2, so half of 3 is 1.5, so negative 1.5. I did something wrong here. Square root of 4 is 2. 2 times negative 1/2 is negative 1. Okay, I knew something was wrong there. Let's try that again. Negative 1, negative 1.5. Then I'll plug in 16. Square root of 16 is 4. That'd be negative 2. That 4 times negative 1/2 is negative 2. So 0, 0. 1, negative 1/2. 4, negative 1. 9, negative 1.5. It's going to be somewhere over here. And there is my function. So, a couple things here. This would be a reflection over the x-axis. It's also a vertical shrink of 1/2. So we've seen both of those vocabularies before. Domain. So the domain x goes from 0 to infinity, and the range goes from 0 to negative infinity. So y has to be less than or equal to 0 because it goes to negative infinity for this one. So that, as I mentioned, the domain and range are going to change for these functions here. This is just kind of a summary of what I just talked about. If a is greater than 0, it's a vertical stretch. Sorry, if a is greater than 1. If a is between 0 and 1, it's going to be a vertical shrink. And if a is negative, then we have a reflection. So all this should be reviewed, just applying it to a new function. Okay, now we're going to do a +2 on the outside. So, again, the value that makes that 0 is 0. We're going to see later on that it's not always going to be 0. So square root of 0 is 0, 0 plus 2 is 2. Square root of 1 is 1 plus 2 is 3. Square root of 4 is 2 plus 2 is 4. Square root of 9 is 3. 3 plus 2 is 5. That should be good enough for me. 0, 2. So basically we're just square rooting numbers here. Now we're plotting some points. Now you can see here, this one moves up 2. This is a vertical translation up 2. And the domain, now x starts at 2, so x is greater than or equal to 2. And the range, y starts at, nope, sorry, lied. X starts at 0. Y starts at 2 and goes up. And so y is greater than or equal to 2. So there's your domain and your range. Okay, I'm gonna just kind of quick talk about these. Vertical stretch for the first one. Vertical stretch and reflection for the second one because that negative. This one's gonna go down 1, vertical translation. This one's gonna go up 3, vertical translation. Okay, now the next part of the video talks about numbers that are underneath the square root symbol. So now the number that's going to make the square root part equal to 0 is positive 4. That's where you're going to start your table at. So 4 minus 4 is 0, and that's what I'm looking for. Okay, so that's going to be 0. And then I'm going to plug in 5. And the reason why I'm going to plug in 5 is because 5 minus 4 is 1, the square root of 1 is 1. And then next number would be 6, no, 7, no, 8. 8 we'd plug in because 8 minus 4 is 4, square root of 4 is 2. 9, 10, 11, 12, 13 would be the next number. 13 minus 4 is 9, square root of 9 is 3. And so you can see you got to kind of play around with the numbers to get them to be perfect squares so that we can actually graph some numbers here. And you can see there, this graph is a horizontal translation to the right 4. Now notice it's negative 4 here, but it moved to the right 4. So that's kind of interesting. It's opposite. We've seen this happen before. So the domain now, x has to be larger than or equal to 4. If x was smaller than 4, so let's say x was 3. If you plug in 3, 3 minus 4 is negative 1. We can't square root negative 1. The domain is that, and the range is y is greater than or equal to 0. Y starts at 0 and goes up. So that is a little interesting. So here we kind of put it all together. We got a vertical stretch, we got horizontal translation, we got a vertical translation. This one's got a lot. It's got everything but a reflection. So the value that makes this part equal to 0 is -4, because -4 plus 4 equals 0. So when I make my table, x, y, I'm going to start with -4. So -4 plus 4 is 0, 0 times 2 is 0, 0 minus 1 is -1. And then I'm going to plug in, how about -3? -3 plus 4 is 1, square root of 1 is 1, times 2 is 2, 2 minus 1 is 1. Alright, then, let's see, plug in -2, no, plug in -1, no, plug in 0, 0 will work. Square root of 0 is 0, and then 0 times 0 plus, or sorry, plug in 0, you get 4, square root of 4 is 2, 2 times 2 is 4, 4 minus 1 is 3. And then let's see, if I plug in 1, 2, 3, 4, 5, 5 would be the next number that would work, because 5 plus 4 is 9. So I'm just trying to get to perfect squares. 9 square root of 9 is 3, times 2 is 6, 6 minus 1 is 5. So there you go. This one's got a lot going on. -4, -1, -3, 1, 0, 3, and 5, 5. And there's our function. Okay, so this one, the domain, x starts at -4 and goes up. The range, y starts at -1 and goes up. So, I don't have a lot going on. Alright, as I said, you get 2 days to work on this. How you approach this is up to you. This is going to be a sample breakdown. No new video for tonight, since I just kind of crammed everything into one video. We'll go over some sample problems in class. Thank you guys for tuning in, and I hope this went well for you.